An angle means several things. One is the amount of opening between two rays. Another is the amount of a rotation, or alternatively, the difference between two directions. Children have experienced angles as turns for years before they pick up a protractor. This activity is important for them to link their experiences with the geometric concepts they encounter in school. It is also important for you, as teachers, to feel what it's like to do this activity. Don't just watch the movie, actually do it. At each vertex of the triangle, there are two important angles. One kind is the interior angle, shown by the people inside the rope with their arm outstretched, and the other kind is the exterior angle, which is the turn you make when walking around the triangle. The blue vector indicates the direction that the walker was originally pointing. Pay attention to when she's pointing in that direction again. Here she's about to make a turn at the vertex. Here's the exterior angle. Now she's made the turn. No turn at all. Compare the exterior angle with the interior angle at the same vertex. Now she makes the turn again. One more exterior-interior pair. After she finishes this turn, she'll be pointing in the original direction again, so she's rotated a total of a full turn, or 360 degrees. Here's the same demonstration without the people, just a geometric demonstration. The vector is shown both on the triangle and in a little circle in the left corner that shows the total amount of rotation for this entire trip. Total rotation was a full turn. Let's try it again with a different polygon, this time with 4 sides, a quadrilateral. Again, the blue vector is the original direction the walker was pointing. See if you can estimate the angles that she turns at each vertex. Was that more or less than a quarter turn, or a right angle? Next vertex, is she about to turn more or less than a right angle? How about this angle? How big was that? And remember, the blue vector is the original direction. After this last turn, she's about to be facing in the original direction again for the first time. So a total turn of 360 degrees, or a full turn. Okay, let's try a star polygon, which is a polygon that is allowed to cross over itself. The best example is the kind of star you draw on someone's paper. Here they're making the star with a rope. And the walker is going to walk around this polygon again, and again keep track of approximately the size of each of the exterior angles, the size of each of the interior angles at each of the vertices or corners, and keep track of when the walker is again pointing in her original direction. Hint, it will happen twice. Here's the original direction. There's the original direction again. She's just turning in that direction, and she keeps on going. She's finished. Now she's pointing in the original direction again. She's made a total turn of 360 degrees times 2, or 2 full turns. We end with some geometric demonstrations suggesting general facts about interior and exterior angles. First, for any ordinary or star polygon, the sum of the interior and exterior angles at a single vertex is 180 degrees, a half turn. Second, for any ordinary polygon, the sum of all the exterior angles is a full turn, 360 degrees. For a star polygon, it's a multiple of 360 degrees. Using these two facts with a little algebra, you can find the sum of the interior angles in any polygon. The answer depends on the number of sides of the polygon. It's easier to see this by cutting out a paper polygon and its interior and exterior angles and adding them physically, as in these demonstrations.